In this video, we will discuss pulse code modulation. Pulse code modulation is a technique in which we convert our analog signal into its corresponding bit. So as you can see, this is a PCM transmitter. From the first block, we are giving the analog signal. So this signal basically is in the analog nature. Now this analog signal is given to a sampler circuit. Sampler circuit, what it does? Sampler circuit converts the analog signal into its corresponding samples with the help of the concept of sampling theorem. What is the concept of sampling theorem? The sampling frequency fs should be greater than or equal to twice of fm, where fm is the frequency of this modulating signal which we want to transmit. So suppose this signal needs to be transmitted and this signal is having frequency fm hertz. So we need a sampling frequency which should be either equal or greater than twice of the modulating frequency. Then this signal is given to the sampler. The sampler circuit will give the various samples according to the amplitude of the modulating signal. As the modulating signal amplitude varies, the sample also will get of various amplitude. Then this signal is given to the quantizer circuit. Now the samples which we are getting are of exact value. Let us say this is 2.3, this is 4.2, this is 3.1, this is 1.3, let us say. So this quantizer, what it does, it converts the samples into its exact integer value, its exact near integer value. Like if the value is above 0.5, it will be the next sample, the next integer, and if it is below 0.5, then it will be the previous sample. So according to that, after the quantizer, this signal will be like 2, 4, 3 and 1. So this will be 2, 4, 3 and 1, like this. So quantizer, what it has done, it has converted the exact values of the samples into its corresponding exact integer values. Then the signal is given to the encoder circuit. Now encoder circuit will check all the samples and it will check which is the largest sample, and that largest sample can be converted into binary bits, but the length of binary bits will be decided by the maximum sample. Like in this case, the maximum value of the sample is 4. It can be converted into binary from by 100 because other samples are below the value of 4. If the sample is more than 7, because till 7 we can define or we can get the samples in 3 bits, but if the sample is 8, then it should be 1000. If it is 9, 1001. That means we have to convert the sample in corresponding to 4 bits. So if the values of the sample are more than 7, then we have to occupy all the samples with 4 binary bits. But in this case, we will be dividing the values in or corresponding to 3 bits only, because the highest sample is 4, which can be described by only 3 binary bits. So the PCM output will be something like this. The decimal 2 can be represented by 0, 1, 0, 4 is 1, 0, 0, 3 is 0, 1, 1, and then 0, 0, 1. So 2, 4, 3 and 1. This is what is the conversion of the samples into its corresponding bit. So this signal is basically known as the PCM signal. So this signal we will transmit towards the receiver. Now the receiver will receive this signal. This signal is passed through some channel, and that channel may contain some noise. So that noise will definitely affect this signal. So at the receiving end, your PCM signal will be looking like something like this. This is 0, 1, 0, 1 0 0 0 1 1 0 0 1. So your this signal will look like this at the input of the PCM receiver. So at the very first block we have connected a quantizer. Now the quantizer at the receiver will not work same as the quantizer of the transmitter. This quantizer will detect the presence and absence of pulses. That means if the signal affects the noise, then we have to consider a threshold value above which we will consider the bit as 1 and below which we will consider the bit as 0. So accordingly here the quantizer will recognize which bit will be 0 and which bit will be 1. So after the quantizer your signal will be same as the output of encoder. So that will be 0 1 0 1 0 0 0 1 1 and 0 0 1, something like this. So after quantizer, this is the exact signal which we have received at the input. This is the output of quantizer, and then the decoder what it does, it converts the reverse operation. That means it will change the binary data into its corresponding sample. So the decoder output will be nothing but 2 4 3 and 1, 2 4 3 and 1. The input which we have given to the encoder will be the output of decoder, because decoder will perform the reverse operation of encoder. So if the input of decoder is something like this, the binary data, the decoder will be giving the output as the samples. Then the sample and hold circuit is the next block. What it does, it basically holds the sample, previous sample, until the next sample arrive. For example, the first sample is 2, so it is holding 2 volts till the next sample 4 is arrived, which is this. Then again 4 will be hold till 3, that is the next sample arrives. Then again 3 volt will be hold till 1 volt is arrived, and so on. This process will continues till all the samples will received or will get converted into its corresponding sample and hold phenomena. After that it will be passed through the low pass filter. This low pass filter, what it does, it removes the high frequency component, and the output of this low pass filter will be nothing but, basically it removes the high frequency component and smooth the curve. So the output of this low pass filter will be this, which is nothing but your modulating signal. So this is how your PCM transmitter and PCM receiver works. I hope this is understood, the concept of PCM and transmitter and PCM receiver. The main disadvantage of PCM is what? Because every sample corresponds to 3 or more bits, so the overall bandwidth of the signal increases. So this is what the main drawback of PCM, which can be removed in other methods which we will discuss in the next videos. For now, if you have any doubt related to PCM, you can write in the comment section.